Okay, this is Mr. Peterson, and we're continuing on page 2 of the 6-2 notes for Algebra 2. All right, we're factoring here, and you notice on example 8 that there is a common factor of 4. So you pull that out, and as soon as you pull that out, you're going to start noticing a pattern here. This trinomial that results on the inside here, and by the way, you could distribute to get back here, but you notice that there's a perfect square on both ends. So this is, in all likelihood, a perfect square trinomial. So we're going to just go ahead and try to factor it that way. And we'll check our answer just to make sure. Okay, to get this 4x squared here, you're going to say 2x times 2x. That would give the front one. To get the 25 at the back, you'll say 5 times 5. And you always borrow the sign of the middle term when you do this. And then we're going to check it. So we've already checked this. That gives 4x squared. The back is going to be positive 25. What we're checking really is the middle term. And when you do the middle term here, you get negative 10x there and another negative 10x there, which indeed gives negative 20x. So that one's done. Okay, the next one, example 9, has a common factor of that a. You'll pull that out and you get x squared minus 9. This is the pattern I taught you where you have a difference between two perfect squares. We call it a difference of squares problem, and they always factor with a plus and minus sign. You take the square roots, so x times x and 3 times 3, and that finishes it. You should check these, so double check here. X times x does give x squared. Positive and negative 3 multiply to give negative 9. And you'll notice there's no middle term on this, so we got to make sure this cancels. 3x there and negative 3x there does cancel out. Okay, the next problem, I should have a graphing calculator in view, but I have to do it without it, so you guys are going to have to pay real close attention here. What we have is a box, and they tell us that the box is 10 inches longer than it is wide. So if we call the width x, this is x plus 10. And it tells us the length, the width, and the height. I'm going to call this h for now, just temporarily. The length, the width, and the height add up to 50 inches. So the height plus the length plus the width have to add up to 50 inches. Now, if we solve for h here, we're going to get an expression that's more usable. H is going to be 50, take away x, take away 10, and take away another x. So the h is going to be 40 minus 2x. So that's the height. And I'm going to go ahead and cross this out and just go 40 minus 2x there instead. Quite a bit more useful when I have everything in terms of x. So now I'm going to go volume is length times width times height, which in this problem is length of x plus 10 times the width of x times a height of 40 minus 2x. And a little bit of rearranging, and we can get this in standard form here in a minute. I'm going to put the x up front. And I'm going to FOIL out the backside. This is 40x. The outside pair is minus 2x squared. And you have a plus 400 there. And finally a minus 20x. So now I have x times negative 2x squared. I'm going to combine the linear terms. They come out to be 20x, and then that 400. Now distribute the x all the way down for my final expression for the volume. Negative 2x cubed plus 20x squared plus 400x. Okay, we're going to graph this. So you're going to type that on the y equals line. of your calculator. It's the top left-hand button on your TI-84. And we have the graph pictured over on the right. So we want to set our window up so ours looks like this one. So the parameters on the window, the minimum x value is negative 15. The maximum x value is 25. The minimum y value is negative 2,000 or close to that. And then at the top, the maximum y value is 5,000. So once you get those four numbers set on your window, then hit graph. And up will pop this picture of what the volume does depending on the width. The width is across the x-axis and the volume is up and down the y-axis. Okay, so what we want to do is first of all convince you that part of this graph is totally irrelevant. In this problem, the x stands for the width of the box. And since the width of a box cannot be negative, the whole left-hand side here gets scribbled out. It's irrelevant. There's no such thing as a negative 5 width, for instance. The same argument can be applied in the up and down direction since that represents volume. And if you're below the x-axis here, you've got a y value that's negative, and that's impossible in this context. Okay, so it's only that center part, looks like a big camel's hump, that we care about, and we're trying to find the maximum height there, the maximum volume. So we got to find the top of that thing. Now the way you do it is you go second, calc, you'll find that above the trace key, and I believe it's choice 4, where it says maximum. Once it's there, it's going to ask you for a left bound. You want to position your cursor somewhere on the left-hand side of that top point. So you want to be on the left side of the hill. And then once you're there, anywhere in this range would be good. Hit enter, and it's going to ask you for a right bound. So you're going to use your right arrow and come over to this side, somewhere in this area. So once that's done, you'll hit enter. And when it says guess, so when it says guess, you're going to hit enter. And your cursor, if you've done everything right, should pop right to that location, and it'll tell you what it is. And I've done this problem. The x maximum is 12.15. And the y maximum is 4,225. 4,225. Okay, so what this is the width in inches, and that's what they asked for in the problem. So that is the answer. And the up and down is the volume. So that's the volume in cubic inches. Now they don't ask for that in this problem. If you go up and read the directions, they're not looking for that. Okay, so the next thing we're going to do here is to find the zeros of this function. The zeros are the x values that make the y turn into 0. And when you have three factors multiplied like this, then and it equals 0, then either the first one or the middle one or the last one has to equal 0. That's the only way a product equals 0. So maybe it's the first one, maybe it's the second one that equals 0, and maybe it's the last one that equals 0. So going from right to left here, if we subtract 4 from both sides, you get negative 4 for the first answer. If you add 5 to both sides here, you get 5 for another possible answer. And here you have two steps. Take the negative 7 over and divide by 2. So 3.5 or 7/2 is the last answer. Now I'm going to show you that this one here actually makes it turn into 0. So if you put the 5 in here, you get 9. If you put 5 in here, 2 times 5 minus 7 would be 3. But you don't care about either one of those, because when you put 5 in here, then this factor zeroes out, and 0 times anything else, no matter, we had a 9 down there, but we don't care because 0 times anything will actually equal 0. So that answer checks. You could take the same argument with this guy. If you plugged him in, this part would zero out, and then the whole thing zeroes out. And likewise, that 7/2 would zero out the front half. So these are the three answers, and it does say to find them by graphing on a TI-84. So if you type that in on the y equals line and hit, I think you could do zoom 6 on this one, then you can use second calc choice 2, and you can left bound and right bound to find those answers. I covered that in a previous note set.